Hi class, today we're going to go through the exercise 10F, which covers minimum completion time. Hopefully when we go through these questions it'll make a little bit more sense of the material. If any of the explanations, if you feel like you need any extra explanation, please let me know in the comments. Okay, so let's start with question 1. Network diagram below shows the time in days for all the activities. Remember, EST stands for earliest start time and LST stands for the latest start time. The critical path on this diagram is shown in red. So we've been asked, what is the minimum completion time for this particular project? Well, we just go to the finish here and we can see that it took 14 hours to complete. So that's the minimum. Oh, sorry. That would be in days, so that would be 14 days to complete. Part B, reducing the time taken in which activity would not result in a reduction in the minimum time. So what we're looking for, anything on the critical path, if we reduced any of these project times, so if we reduced A, activity B, activity D or E, it would in fact reduce the completion time for the project, because the critical path is kind of the path that takes the maximum amount of time to get from the start to the finish. And it's called a critical path because we need to start everything straight away. And you can see here the EST and the LST along the critical path for each of these activities are the same number. There's no time in between. We have to start them immediately. So it's this project here, project C, that we can reduce, but it won't reduce the minimum time. So we could reduce C, we could take 5 hours to complete C, but it's still going to take 14 days to get through the project. We could reduce this down to 1 day. So we could do activity 5 and then we could go straight on to activity C, and if you're in team C for instance, that'd take you, 5 plus 1, that'd take you 6 days, but you'd still have to wait 8 days for this critical path to get finished. So it's activity C that we could reduce, but it's not going to bring down that minimum time. Part C, activity A was reduced in time to 3 days. So if we reduce that to 3 days, what would be the new minimum completion time for this project? Well, it's A is on the critical path. We've reduced it by 2 hours. So this should reduce the project by 2 hours. But we should also just make sure, and if I just go back and erase this bit here, we should always make sure that this other path wouldn't then become the longest path. In this case, this would still take 9 hours, so 12 hours in this case would be the maximum time, or in this case, the minimum completion time, so 12 days. On to question 2. In question 2, a network diagram below shows the time in weeks for all the activities. The critical path is given in red. So we can see the critical path just really quickly. 9 plus 5 weeks plus 3 weeks is 17 weeks. So if you add up all the project times on the critical path, it should be your minimum completion time. Part A, what is the minimum completion time for the project? Well, that will be 17 weeks. I'll just put W for weeks. B, reducing the time taken in which activities would not result in a reduction in the minimum time. Well, just so like we saw in question 1, anything that is to do with activity A and B or activity C won't result in a change in the time because they're not on the critical path. So we could reduce, by reducing B to 2 or to 1, it's not going to reduce the overall time because this path here is still the longest path and it's still going to take 17 days to go through that. The last question, activity E was reduced in time to 1 hour. So activity E was reduced to 1 hour. Now, I'm going to assume that's an error because the question is talking about weeks. So let's just see if we change that to 1 week. Activity E goes to 1 week. What is the new minimum completion time? Well, if we just go through the critical path, we've got 9 plus 1 plus 3 is 13 weeks. And if we just make sure that nothing else goes above 13 there, so we've got 7 and 3, we'd have 5 plus 3 plus 1 plus 3. And so that would be 13 weeks would be our new minimum completion time because of that reduction. Question 3. The network diagram below shows the time in hours for all activities with the EST and the LST given. The critical path is shown in red. So our critical path is activity A and activity F. 5 plus 13 gives us 18. The minimum completion time for this project is going to be 18 hours. Reducing the time taken in which activities would result in a reduction in the minimum completion time. So anything on the critical path, so either activity A or activity F, if we reduce those, they will reduce the overall time. As an example, if I was to reduce F down to say 10 hours, then our critical path would be 5 plus 10, which would be 15 hours. The last part here, part C, activity B was reduced in time to 5 hours. What is the new minimum completion time? Well, activity B isn't on the critical path, so the minimum completion time hasn't changed. So in that case there, the minimum completion time is still going to be 18 hours. Changing anything on these paths down here, they're not on the critical path, won't change the project time. To minimize or to make the minimum completion time a shorter amount of time, we have to reduce one of the projects or one of the jobs on this actual critical path. Question 4. Network diagram below shows the time in minutes for all activities, the EST and the LST. The critical path is shown in red. So again, we can see activity A, C, E and G are along the critical path. And if we look at the finish time here, it's going to be 14 minutes to complete this project. Part A, what is the minimum completion time? Well, it's going to be 14 minutes. Part B, reducing the time taken in which activities would result in a reduction in the minimum time. So we want to reduce anything on the critical path. So if we're going to list that, anything activity A, activity C, activity E, or activity G. They're the activities that we could reduce to reduce this overall time. Part C, both activities A and E were reduced by 2 minutes. So activity A was reduced by 2 minutes, so that'll become 6. And activity E, instead of 3, will become 1. What is the new minimum completion time? So if we go through our critical path, we've got 6 plus 1 plus 1 plus 2 for a total of 10 minutes along that path. We then just have to check, if we go along this bottom part, we've got 6 plus 2, which is 8, plus 1 is 9, plus 2. Coming down this path, it would take 11 minutes. So by reducing E and A, what's in fact happened is this path down the bottom here has now become the critical path. And so the new completion time for the project by reducing A and E is now 11 minutes. On to question 5. Question 5, the network diagram for a project is shown below. The duration for each activity is in hours. Identify the critical path for this project. So this project, we can see at the finish here, is going to take 22 hours. What we're looking for is a path where the EST and the LST are the same for each activity. So we can see from the start here we have 0 and 0. And then we've got a 6 and a 6 here. We've got an 11 and 11, 19, 19, and 22, 22. If we were to follow that path, so from B through to activity E, activity H, and to activity J, this would be the critical path. And we can write that down as follows. So that's activity B, activity E, activity H, and activity J. That will be our critical path. And just to remind you to identify that, just look for any path where the EST and the LST are the same. Part B, what is the minimum completion time for the project? Well, that's 22 hours. What is the maximum, part C, what is the maximum number of hours that the completion time for activity E can be reduced without changing the critical path of the project? So E, it's going to take 5 hours to complete activity E. And what we're looking for is other paths. How far can we reduce this by so this is still the longest path to get to this point? So it takes, along this path now, it takes activity B and E 11 hours to get to this path. So if we look at this crucial junction that E comes into, around this side, if we go activity A, activity D, that takes, I'll just write it up here, that takes 7 hours to get along this path. This one here we know takes 11. And the only other part coming into this junction is this path, activity C, F, and G, which takes 2 plus 4 plus 3. This takes 9 hours. So if we want this to be maintained as the critical path, it has, this number has to remain the largest number. So we could reduce this at most by 2 hours to get it down to 9, and this would still be technically the critical part, even though it would be the same as this path down here. So we could reduce E by 2 hours, and it would, so it could technically be take us 3 hours, and then 6 plus 9, 3 would still give us 9. Part D, what is the maximum number of hours that the completion time for activity H can be reduced without affecting the critical path? So again, we need to have a look at H here, assuming that we haven't changed E in this case, and I'll just get rid of a few of these parts here. So H comes into this junction here, and to get to that junction, this path takes 19 hours. The only other path into that junction is along the bottom here, which is activity C, activity F, and activity I. If we add that path together, we would get 2 plus 4 plus 7, which is 13. So we can reduce H and keep it on the critical path if this remains more than or equal to this number. So we could reduce H by 6 hours, because this is 19 and this is 13. There's a difference of 6. So we could reduce this technically down to 2, and it would keep it as the critical path. So the maximum number we could reduce that by would be 6 hours. Part E, if activity B is reduced from 6 hours to 4 hours, so here's activity B, if we reduce that to 4 hours, what is the minimum completion time for the project? Well, I might just go through and just free up a little bit of room here. So if we're reducing B to 4, the completion time for this project, if we go through the critical path now, this one along here, this is going to take potentially a little while. This path to this junction here would still take 7. Along this junction, this one's going to take 9. And I think if we go along C, F, and G into this junction would be 9. So 9 would be the earliest start time for activity H. H isn't going to change, so it'll still be 8. So when we get to this junction, potentially coming down here, we're going to have 17. Going along this path from before, this is going to be 13. So this number is going to be the largest of the two numbers coming into that junction, so that will be 17. And J takes 3 hours, so by reducing that by 2 hours, this will remain the critical path, even though there is another path here that could be down as the critical path as well. But it's reduced by 2 hours. So what is the completion time of the project? That would be 20 hours. Now you might say to yourself, well look, it's been reduced by 2 hours. Couldn't we have just gone 22, take away 2? We could have done that, but it's always a good idea to check to make sure that that path would remain on the critical path. If this path down here happened to be, let's say, a 10 into this junction and this only reduced to 21, the minimum completion time might have only gone down by 1 hour. On to question 6. Question 6, there are no ESTs or LSTs given to us, so we're going to have to go through and do that for each activity. To do that, let's go some forward scanning and then some backward scanning. So our forward scanning, we're going to start at this junction here, and we've got activity A and B. Anything that starts from the beginning, the earliest start time will be 0. If we go along activity A, this takes 5 hours to do. So the earliest we can start G would be 5 hours. B takes 1 hour to do. And so we get to here, the earliest we can start this one here would be 1 hour. Activity C, that takes 2 hours, so the earliest we could start E would be 3 hours. But before we get too carried away with ourselves, we have to remember that coming into this junction here, in order to go down this path or this path, we have to have completed all the projects coming into that. And this dummy activity is a way of connecting A back to this, the end of A back to this junction. So what it means is to proceed past this junction, we need to have completed activity B as well as activity A. So in this case here, that means that the earliest time we can start either of these two activities, and I have it on my diagram here, got a little box for activity F, but the earliest we can start this would have to be 5 hours, because we have to wait before activity A is done before we can proceed with activity F and C. So now activity C, that takes 2 hours, so activity E will be 7. Plus 7 to do activity H, we would have to, earliest start time would be 14. And that would take 4 hours. And so I'm coming into a junction here, and so I'm just going to write the number 18 here, because coming in through this path, it's going to take 18 hours to get to here. But we have to investigate the other two paths leading in before we can write this EST for this particular job J. So if we go back now to this part here, so the earliest start time for F was 5 hours. It's going to take 12 hours to do that. So coming into this junction again, going down this path, it's only going to take 17 hours. It's the shortest path. So it's not going to be a critical path. At the moment, this one here is the maximum, so it's our critical path so far. If we have a look over the top now, this last path, 5 hours to get to this junction, another 3, so this would give us 8 hours, and another 8 hours, this would give us 16 hours coming in. So the 3 paths into this junction, the one that would take the longest is 18, so the earliest we can start this is 18 hours. Yes, this job and this job will finish beforehand, but we can't start this one until we've finished all of these jobs. So that's why the minimum or the earliest start time, it might sound counterintuitive, is the actual largest number coming into that junction. J takes 1 hour, so our finish time and our minimum completion time for this project is 19. If we go back through and do our backward scanning now, for the finish time the LST is always the same. If we come back to this one here, we would subtract 1 hour. So here we've got LST is 18 at this junction. Subtract 4 would give us 14. Subtract 7 would give us 7. And coming into C here, subtracting 2 would give us an earlier start time of 5. Now you might notice that these numbers here are all the same. And the significance of that, I hope you realise, is that this is our critical path, or will make up part of our critical path. If we have a look at now, it's 18 is the EST here. If we take off 12 here, the EST at this point for F is 6. That means we could start 6 1 hour after we start C because of this 1 hour lag time here, and still get to here in a sufficient time to start this last project. If we come across this top path now, 18 take away 8 would give us 10. 10 take away 3 would give us 7. And if we have a look, we've got a junction coming back where we've got 3 jobs coming in here. Along this path here, we've got 7 hours coming in. Which means if this is 7, if we take off 5, this is going to give us a latest start time for A of 2. Now, we might get back to here to junction C again, and we can see that the latest start time there is 5. And if we then proceed along this path for job B, we're going to see that if we go 5 take away 1, we would get the answer of 4. But hold on a second, we've got 2 jobs now from the start B and A that have a later start time. Now one of them has to be equal to 0. One of these jobs we have to start at the beginning. This is suggesting there's a lag time for both. Now, I hope you can see, because this is a dummy activity here, technically coming into this junction, there's another way to come into this junction going backwards. And that would be from job C up along this path here. Now, 5 take away, now ask yourself, how long does a dummy activity take? Dummy activity takes 0 time. So 5 take away 0 would be 5. And in fact, coming back into here, now this is the later start time for G. It can be this is a little bit confusing, I understand that. But now if we take this number here, the smallest number, 5 take away 5, would give us a later start time for A of 0. So it's A that we need to start straight away. And in fact, if I get out the yellow highlighter, there is our critical path, or the finish of our critical path. So I'm going to highlight that and bring it back onto our other slide so we can answer the questions. There we go. Okay, so it says part A, find the earliest start time and the latest start time for all the activities. Well, we've done that. Part B, identify the critical path. Well, we've done that as well, but we'll just go through, and if you had to write this in an assessment task, you'd have to label or list all the projects. So that's project A. We don't have to write anything for the dummy activity. It would then be activity C, activity E, activity H, and lastly activity J. Part C, how much time overall is saved if activity F is reduced in duration by 2 hours? Well, activity F, if we reduce it to, what would that be, 10 hours. Coming into this junction here, this would reduce this to 15. F's not on the critical path, so reducing it will not reduce the project. And so that will reduce by nothing. Part D, if only one activity can have its duration reduced, what is the maximum possible reduction in the completion time of the project? So that's a pretty challenging question, this one, but we have to look at this junction here. Actually, let's look at this junction back here. It's the difference between these two is the most time we can save. So we have to start this one at 0, this one at 4, which means we can sit around before starting B. If there's a team doing B, they can sit around for 4 hours before they have to start. If we somehow reduced activity A, it's the only one in this project we can reduce. And we can reduce it by 4 hours before this would become the critical path. If we reduce that by 4 hours, we'd get 2 critical paths in this project. So it would be activity A, and we would reduce by 4 hours. That's a pretty challenging question. Let's move on to the last question now, which is question 7. In question 7, there's a network diagram shown below. The duration for each is given to us in hours. We need to go and work out the EST and LST and determine the shortest time of the project and write down the critical path. So just like we did for question 6, let's go ahead and do that on a separate page. Let's go through firstly and do our forward scanning. So we've started the junction for the start, and we've got 2 projects, A and B, coming off that. Both of those, the earliest we could start those is at 0 time if we wanted to. If we go down this path, first of all, because they're going to meet again here at this junction, I'm going to come and work out these 2 first. If we start at B, B would take 5 hours, so 0 plus 5, the earliest we could start C would be 5. C takes 2 hours, and so we get to this part of this junction, and it's going to take 7 hours to get to here. If we go along here, along this path, project A takes 6 hours, so it would take 6 hours to go along here. And so the earliest we could start, we have to wait until both of these projects are done. So the earliest we could start E and D, so here's D up here, the earliest we could start both of those would be 7 hours. See, we can't start D until we've finished both A and C. So the earliest we could start this would be 7, and the earliest we could start E would also be 7. We then go, we're going to meet another junction up here before activity F, and there's 2 paths, D, then with a dummy activity, so this path takes 4 hours, 7 plus 4 is 11 coming in from this junction, and 7 plus 6 would be 13. We have to again wait for both of these to be done. So we're looking for the biggest number here. The earliest start time for F would be 13. F takes 2 hours, so our project is going to take 15 hours in total. It's going to be the latest start time here. We then go backward scanning, so we're taking these times away. 15 take away 2 would be 13. 13 take away 7. So this would be, 13 take away 6 would be 7. 13 take away 4, so for D, the latest start time would be 9. So you can see just by comparing these that our critical path, E is going to be on the critical path, D will not. There's a bit of lag time there. We can start D 2 hours after we start E. If we then follow from this junction back down this way, 7 take away 2 would give us 5. 5 take away 5 would give us 0. So we have to start activity B straight away. And in fact, we could come along and highlight this path here, and that will be our critical path for the project. And just to go off and finish this last one, the latest start time into this junction would be 7 hours, and if we take away 6, we get back to 1. So we could delay starting activity A by up to 1 hour to get to this junction in time to start by 7. So I'll take another screenshot of that one there, and we'll paste it back on our main page. Okay, so it looks like we've done A, B, C, and D. Part D. The time it takes to complete activity A can be reduced by 1 hour at a cost of $50. Explain why this will not affect the completion time of this project. Well, as we stated here before, we can delay A by up to 1 hour its latest start time. So if we were to reduce this by 1 hour, it would reduce that back to 0, and in fact both of these paths would then would take exactly the same amount of time to complete. If we were to go down this path here, the non-critical path, the 6 plus the 4, we would only be reducing the project by that 1 hour. In this case here, that would be a waste of $50 because on this critical path, it's the longest we have to wait. It's still going to take 15 hours whether we reduce that by 1 or not. If we reduce it by 2, however, it would become the new critical path. Last question. Activity B can be reduced in time at a cost of $100 per hour. So this activity here. Activity E can be reduced at a cost of $50 an hour. What is the cost of reducing the completion time of this project as much as possible? If we just have a look at the lag times here between these two, there's a 1 hour difference between the start times of these that makes up a crucial difference. So by starting this one, or saving 1 hour on this job, would make both of these parts equivalent in time. So if we made this 4, we'd have a 4 and a 2, which would be 6 to get to this junction, and this would be 6 as well. So the most we can save on here is 1 hour, and that would cost us $100 at this $100 per hour rate. If we have a look at E, E goes from this junction here to this junction, and the only other project in there is D. Now D takes 4 hours, so obviously we could shave off 2 hours off E, and it would be equivalent to this path D. If we were to shave off 2 hours from E at $50 an hour, that would be another $100. And in fact, to reduce this project to a bare minimum, which would be 2 plus 1 would be 3 hours, down to 12 hours, would cost us a total of $200. That was a pretty advanced type of question. It's probably a band 5, if not a band 6 style question. I hope going through those with you, that's about a 32-minute video. Hopefully it's been useful. If you've got any questions, please let me know.